Hello and welcome to our webinar on digital language development. Language is one of the most fundamental and complex aspects of human communication, and over the years we've seen remarkable advancements in language technology. And one of our most significant developments in this field is the emergence of large language models. My name is Maja Magnusson and I will be your host today. I am co-founder and COO at Care2Translate. If you don't know what we do at Care2Translate, we develop digital translation tools to enable communication in healthcare settings. So if a healthcare professional is meeting a patient that doesn't speak the same language, you can use Care2Translate to overcome those language barriers. And we are really excited to see our tool being used all over the world, and also the public healthcare organizations starting to use our product now. I'm also very excited to be able to welcome today's speakers to our webinar. The first speaker is Stefan Palm. Stefan will speak about the promise of large language models and specialized domains. He is from IBM, and very welcome to you, Stefan. We will also have Alexander Gyllensvärd presenting today. Alexander will speak about the challenge of developing a language app for healthcare. And Alexander is our very own CTO at Care2Translate. And last but not least, welcome to Arne Ranta. Arne will speak about powerful grammar-based technology to scale across languages and domains. And also very warm welcome to you again, dear audience. I want to invite you to participate in today's discussions by asking questions in the chat or adding your comments in the chat. So please take the chance to lift any thoughts or ideas you might sit on today. But before we let our speakers present, I want to rewind a little bit and see where it all started. And machine translation has been an active research area since the 1950s, when the Georgetown IBM experiment was conducted to translate sentences from Russian to English, as you can see in the example that I am showing here in this picture. So machine translation has been researched since the 1950s using rule-based approaches and later statistic models. And more recently, large language models based on deep learning, such as Google's neural machine translation, and also OpenAI's GPT models have advanced machine translation and natural language processing by processing vast amount of data and generating more accurate and human-like language. But given that this has been a research area for the past 70 years. And when it comes to the number of languages we're using globally, which are 6,000, we are still only working with about 100, a little bit more maybe currently. So my question is, how far have we actually come the past years? And how far will we be able to go? And I don't know if Stefan can answer my question, but he can definitely shine a light on the development currently. So I'm again really happy to welcome you, Stefan. You are from IBM, and given where it all started with the Georgetown IBM experiment, it feels just right to kick off the webinar with you as our first speaker. As I mentioned, Stefan will speak about the promise of large language models and specialized domains. Stefan Palm works at IBM as architectural advisor for startup organizations that enable and realize innovative services and applications in a user-friendly way. And in the most recent years, you have collected a lot of experience and knowledge around developing and operating AI and ML. So very warm welcome to you. I'm gonna stop sharing my screen and give you the sharing.
Thank you. I am old, but not that old. I was not part of IBM when we did that punch card experiment. It was actually for a World Fair that was demoed, so that was pretty cool. Actually, nice touch to bring that up. I didn't know it. So let me see if the technology is with me. You should see my screen now.
We can see
it. Good. So let's bring up the elephant in the room, the ChatGPT. Maja, will you do a poll on the audience? How many people have used ChatGPT? The splendid idea someone had that instead of having AI people working in the basement doing stuff that nobody understands, we put the chat interface in front of it and let people use it. Is it good or bad? What do it do? Most people, I assume, have read about it. Some people say it's the holy grail to be the generic AI capabilities. School students, of course, use it. But some also on the right-hand side claim it's wrong. It's just used to produce a lot of fake news and fake fact. And the legal debate on what training data is actually used, do they actually have consent to use it, and the things produced, who's owning that one, is kind of a mess. So this presentation will start off very quickly with a foundation on knowledge. And then I will bring into some details on how this actually works. I don't think you will understand or actually remember everything, but you will hear about things that you will understand why this is a great technology and why you should be a little bit cautious.
Just giving you some numbers here, Stefan. So about 58% have actually used ChatGPT, just so you know.
Okay, the other 42%, you really have to try it. It's an amazing experience. And you will be astonished what the results will be. But after this presentation, you might think a little bit different. But the fun part is that by providing the service to the public, the expectations of what the AI can deliver in the organizations have risen. And what enterprises and what companies like IBM is working with doesn't really try to bring these values to the employees. And then you start to figure out why is this. It's kind of a challenging environment, but I will get you through. The thing is, behind this scene, it's a lot of different models. So ChatGPT got the most press, but now Google brought them forward, and it's a lot of different names. My name is Stefan Palm, and it's just found that on the top on the list is a model called Palm. That's pretty amazing, it is. But generic, it's trained on very large amount of data, think the whole internet. And the thing is that the model over time gets bigger and bigger and bigger. And then you wonder, why is that? Because there are things that emerge in these models. It's very clear that we don't understand how this technology actually works behind the scenes. A lot of researcher is trying to promote how it works, but it doesn't. So for instance, suddenly a model, if you top right-hand graph, understands Persian that has not been part of the training data, and suddenly you can ask question and they respond to it, totally unpredicted. So that's a kind of a fun thing, and that's scaling us. But the complex thing as a user is that which model then, if it's several models and they are getting new, who should I choose as my winner? And the response is depend on what you want to do. So the different models are good at different things. That's so it's depend, the boring answer. And it's depend on what data that are used in the training. Remember that this is machine learning. So the models, knowledge in the models is depending on the data. And of course, the information is based. Well, we are running out of the model of the data sets in the world here, and that is kind of scary. because now we are mixing data that we don't have control over. So when we are claiming that these models are so good by testing them, it shows up that the answer to the question actually is in another training data set. So it's kind of not hard to understand that the model, if the train of the data, will be able to respond to a test question, that one. So it's when people claim the models can do things, have that a little bit in the judgment. The other part is that these big models now are getting so big, it actually starts to be a scarce resource. There are very few organizations in the world that can train these big models now. And that is another debate on how actually our public society can get benefits from models that only private companies can train. But not only train them, but actually to operate them is now both a power or a question of resources, skills to run this. So of course, the same thing happens with every technology evolution. Now the new focus is how do we actually scale this technology down so we can actually use it in production in the most sensible way. And it's very good indications that it will do that, be a technology that can scale downwards. We can see that roughly you can scale it down 40% and it deliver like 60% more efficiency in there. So have a little patience. It will come smaller models that will do this great stuff that ChatGPT will do in a more controlled way. So understanding this basic, then now we will have a little bit of going in a little bit deeper. I will try to explain this in a good way, but have patience with me. So the basic architecture in this model is that you take in some text or some input and you encode this to numbers. And I said that again, computers deal with numbers, not text. And then you can decode it to produce an output, a text or image and everything. And these models have different capabilities. You can have a combination of both encoders, decoders, or different ones. So the different capabilities, different architectures. You will get to know everything. So you can claim you know everything of this one. It's great. So let's encode stuff. The basic set is you take a text string and you do it to numbers. The trick that these new models actually did solve that no one had done before, basically we didn't have the compute power to do it, is to pay attention in what context the word that we are coding exactly exists. So to the right hand side, you see the term it, that if you just code the word it is kind of meaningless, but now you can see it is actually had a relationship with animals and other stuff in it, and you actually encode the relationships in the same sense. So it's very complex encoding done in these models. And that's the trick on actually get this to work, is the complex encoding. The fun part is when you get encoded data, suddenly you have structured data. The text is unstructured, but now we actually can create relationship, and you don't have to read the words in here. But you get on the left-hand side, you get relationships between words. So you can do easy classification and see what the words that are in the same area. This is printed in 2-dimensional, so we actually understand it. But in models, this is done in like 500 to 2000 dimensions, but we are not able to grasp there. But the fun part is also that if you seek for other relationships, you actually can start seeing the language structure emerging in these encodings. So we can see what part of speech is actually the words belonging to. And the latest findings is actually that these models is actually learning the rules of language in here. And that's why they are so good at producing text that sounds so good. Or that someone else claimed to say, our language may not be as complex as we thought. These models learn to decode the language structure we're having. And I just want to go back to the point that Maya said, that remember that the training data on internet today are mostly in English. I think it was a model I saw we used 29 languages. And there are a lot of languages in the world that is not compatible with this set. And I think that's a huge challenge. And how do we get all the languages to be using this technology? And that's one area that we actually, from IBM, is working on. But remember that we have the languages here. To produce the text, the decoding part, when we take the numbers and try to do a word, it's statistics, as it always has been. We predict the next word. Remember that in practical, this is kind of complex because we are in so many dimensions, but you try to find what the next word. So if you have a beginning of a sentence and you want to predict the last word, you get a prediction score, and then you can say, which word should I put in the sentence in here? And when we are generating large texts, it's no rocket science. You actually do word-by-word predictions. So you take a beginning of a sentence, you add one word, then you take the whole sentence with the extra word, put it in, and you got the prediction to the next word, and then you put it on over and over again. In the beginning, you did that in a strict way. I took the most likely word. It became very boring text, a lot of repetition going on, because if you got the same prediction on the top every time. So they canceled that down pretty fast, and they introduced some randomness, I call it, when we talk today, so you just understand. We're actually not always picking the word on the top of the list. We're actually, sometimes we pick something else from the list. And this way we get some more interesting text. We get a lot of variations in there. So the randomness part is very important for these models to actually work. Okay, so now the tough part in here. As I stated in the beginning, and that false name, that large language models they are called, they actually don't deal with language. They deals with tokens. So remember the process of encoding. We take a text and do to the number. We actually don't have for every relationship a word have in the text will be a lot of things. So we actually have some tokens for words or some tokens for part of words. And there are three big differences the different models are using, and they are good at different stuff. You just have to remember there are different ways of making the word into a token. The good thing to know is that in context of healthcare, they are sometimes very strange words. And in a normal tokenization operation, these words will be generated of several tokens. So what you can do with a smaller model like this model, they make a tokenizer that take every word, the complex word for each token. And in that way, they can actually produce a much better result in this specific use case of complex word in medical terms. So that's how you can actually tailor the technology to a specific use case, is to look at this. How do I actually make the tokenizer in this model in here? So that's good. So now when you understand randomness and you understand tokens, you will soon understand why these models do what they call hallucinations. They are drifting away and producing text that doesn't make sense at all. So when we're doing this random, if we have next token is a word, we can actually just produce a random word that doesn't have to be relevant to the context. And you can also think of a word combining of several tokens. Then the model are very capable of inventing new words, as we have seen examples, I think. And remember, when we do word-to-word prediction, you are taking the whole input and just pick the next most likely word in next word. If you are then putting in a random word in here and use that for predicting next word, you can take off in a completely different way with your text. And that's why it's called hallucinations. It's basically to go out there. So sometimes you get away with it. It's just an outlier in the whole context, and the story continues, and it just be a false fact. And sometimes the story will take off because they introduce some random word in there and they go in there. And these are the critique now with this model, is that you don't have any fact checking of the results. And that's maybe okay for end user consumer service that I use. But if you're going to use this in an environment, basically giving healthcare and advice, you must know that the results produced are correct. And there are no such things today in this technology out of the box. You have to do this outside. Another issue is with this, when you're generating these, you don't have any link back to the training data. So when you're producing a text claiming a fact, we don't know what the model actually picked up that knowledge from. There is no reference back there. And that's also something, if you look from a healthcare compliance sector, it's a huge issue. So how do the ChatGPT do this today? Human in the loop. When the model produce results, they actually monitoring the results, and there are people sitting and correcting the model's results by hand. This labor is kind of a dark side of this industry. It's happened in places with people working for low salary, so it's not really something nice, but I just want to make you aware of that. There are stuff in here as well. So how do you increase your odds to get better results from the model? Some people that have tested this may know the term prompting, more correct term maybe in context learning. Remember that the predictions for the next word are made within the context. You can cheat a little bit then to actually put things to the input memory, the context, before you ask the questions. So that's pretty interesting. So if you want the model to respond as the text was written by Hemingway, you just maybe can put it in because he knows who Hemingway is, and you get the text in the style of. That's pretty interesting. But remember that different model has different input sizes, how much things you can do in there. Something you may see, the thing you write, and there's some models actually have hidden instructions to try to prevent that the responses are not something that people will react on in there. The fun part is that we can actually do that with different multimodal, so we can actually put in both image text and get an image to get a text and stuff like that. I think you have seen the both of it. So prompting is a very useful way of actually getting some results. And also the last example I have here is the math example. It's actually these language models actually can calculate. But if you give them an example, of course, somewhere in the training data set, they're having the letters 1 + 1 or 2 + 2, so they can fetch the result. But it actually cannot do anything. And that's a segue into if these models are intelligent. Not really, in my position. It's based on statistics and on the context you have. What's the tokens? They don't really have any logic built in the model by classic definition. There are people that claim that this is a new way of reasoning, computer way of reasoning that we humans can't grasp, but that's a theoretical discussion. I won't go into there. But again, you can help the model simulate reasoning by adding to context. So you can say, argue in this way, and it will do that. It will repeat the pattern, but it's just repeating. It relies on steroids. And also, when we say intelligent, don't underestimate the human ability to find patterns. I don't know, but my coffee machine have an emotional state I don't like at home, so I attribute it to something it doesn't have. Many people give their lawnmowers names and stuff like that. So we humans are fantastic to say that things are intelligent that are not. This might be another case actually in this way. If you want to have a fun thing to do to test it on what knowledge and how intelligent it is, you can use paraphrasing to actually see. So it's very easy for the models to respond to a direct question. But if you do a paraphrase question, the models tend to get much more trouble to actually do some reason. Also interesting is that the model doesn't really have the concept of I don't know or I'm not sure. So they will killgissa, as it is in Swedish. They will give you an answer and be very sure that this is correct, and they are very convincing. So that's a cool thing, and I just wanted to end up with that. Remember, this technology, we are talking about text, but this is multimodal. It works great to having images as inputs or outputs for the decoder encoder part, and you can swap modals between, so you can do text input and graphical output. That's how you generate pictures in here. Audio, or in this case that our friends in IBM Research, they actually took the language of grammar of molecules that it says here, decoding how you work with proteins and stuff like that. So the technology is really promising, actually. So wrapping this up, I think this is excellent tools for generating inspiration. I use it myself, but again, fact checking is not part of included, so you don't know if it's actually true information you get in there. And you don't know what information come from, so from a source of information is kind of useless. And the management of training data is really not in place, so you really need to have guardrails to know it, and it might be a legal problem in the far end in there. But from the technology point of view, you can actually tailor it then to specific needs. And the easiest is that you have the whole traditional data set and train your own model, or you take an existing model and fine tune it with your data set to get the relevant interface. The technology great, you can scale it down and use your own data sets in there. And to explain everything that happens in the research community is kind of hard, because people are optimizing on research problem, as I call them. They try to get smart solutions to publish paper. But in reality, performance is our biggest problem. How can we actually get something that works, that actually doesn't cost more than the problem that we're trying to solve? And today we can see that many problems that don't require large models, we can solve them with smaller models actually in production. So that's the reality today. So, finishing up.
Thank you so much. Yeah, we are with you.
Oh.
Thank you, Stefan. This was really interesting. I mean, I'm not sure how tech savvy the audience is. I think we have everything from a language nerd to maybe people interested in using apps, but I think this was a very good level for everyone to understand. So thank you for that. And before moving on, you were touching a little bit upon how you see the use of these large language models helping us moving forward. Do you have any ideas, suggestions how the healthcare industry could make use of the large language models moving forward?
Yeah, so there are actually a couple of tailored models that are trained on medical data. And again, I think it's the cautious is the governance process of how do you know what data is used, and how can you secure that the results are good there. But I think that's guardrails that must be put in place anyway. But I think it's you will get, with the large language models, you will get the benefits of the scale, and I say the ability to get in there. But you have to put in the extra work to get the specific results you want to have. So it's a little bit of work, but for exploration, I think it's good. And again, if you look at the customer care area with translating languages, you will have huge benefits of this for like social interactions and so on. But again, I tend to separate the social interactions from the actual facts. So it's kind of a two-layer. You can be nice, but you don't know what you're talking about. so you have to be really careful when you trying to apply the technology back to the action when you want to provide correct facts. If you're depending on some assistant to a doctor, really have to be good. I used to say that generating a picture, usually when you do that, you do like 10 different picture or 10 different text, and then you use one. So that's like a 10% accuracy in that model. It's not really good. So we want to be up to 95% accuracy, something like that. So we have a little bit of work on that. But again, I think it's try to use it as a user, get used to it, and I say don't think about how you digitalize your process, your work today. Try instead to say, if you want to do work in another way using this technology, how would you do it then? So redefine the process with the help of this new stuff. I think that's the fun part. So how can we interact with the caretakers in another way if we use that kind of language models?
Thank you so much, Stefan. And we will get back to you very soon. And I think this is a very good transition to our next speaker, who is, as I mentioned, our very own CTO, Alexander Gyllensvärd. And Alexander will talk exactly about what you just mentioned, the challenge of developing a language app for healthcare where you actually need to be 100% correct. So there are certain phrases which we don't want the healthcare staff or the patient to understand incorrectly. And before handing over to Alex, I would like to ask the audience, have you ever used a translation application in a healthcare setting? So either maybe as a patient talking to healthcare staff that didn't speak the same language, or as healthcare staff. So let's see what you guys answer. And just to introduce Alexander a little bit more, he's our CTO, and he works basically with all tech-related things at Care2Translate. And this includes anything from setting up cloud architecture to leading product development and design. And he joined the company as co-founder in 2019, and has since worked in improving our product from all possible perspectives. So let's see if you have answered anything. And most of us in the audience have not used a translation app in healthcare settings, and about 20% as a patient and 20% as healthcare staff. So that's quite interesting. Let's see what you have to present today, Alex. Welcome.
Thank you so much. And thank you, Stefan, for the incredible presentation. It was a lot of fun just listening in. Even if I didn't understand everything, it was a very good sort of way of understanding more of the technology behind it. So let's see if I can share my screen. And I'm probably going to have a quite lower level when it comes to the technological parts. So I think that's good for some in the audience as well. I'm going to talk about the challenges of developing a language app for healthcare. And Maya already introduced me, but I also just want to mention that my academic background is in communication. So that's sort of where I found my inspiration for technology in general. And that's sort of how I view technology still today. But for the last 6 years, I've been working within software development and with digital products. And to first give you sort of context of how we're working, I want to introduce the tool. I know that maybe some of you already know what Care2Translate is, but some of you may not have heard of it at all. So Care2Translate gives doctors, nurses, and caregivers a tool to give information, give instructions, and ask questions. So when the healthcare personnel don't speak the same language as the patient, they can still make sure that they can make themselves understood in a way that you can still bring the session forward. Then the patient can also answer by either saying yes, no, by using gestures, by pointing to, for example, parts of their body, or by clicking on answers, as you can see in this image. What I also wanted to show is for this presentation, I want to talk about what Care2Translate is not. So Care2Translate does not give a tool to have thorough dialogues. It doesn't give a tool to ask open questions. And it does not give a tool to translate on the fly. So when we're talking about the use of language models and modern language technology, I think that it's important to know that what we're doing right now is we're translating exact phrases, and translating those into specific languages that we're working with. And I feel like many of you wonder, and many of our customers or potential sort of clinics and hospitals that want to use the app are wondering, is why is it like that? Why can't you just enter whatever text you want and then have it translated on the fly? And I'm going to talk to you about the challenges from our perspective. So first of all, what are the challenges? To get a good first response to this question, I actually chose to ask the source of language models, or like the latest thing that also Stefan talked about, ChatGPT. And the response was, as expected, quite incredible. I'm going to show you, and I understand that it's hard to read all of this, but I want to highlight some things. So I asked if language models should be used in a healthcare context to talk to patients. And it gives me, first of all, it says that it's not qualified to provide medical advice, stuff like that. It says that it's good at like generating text. But some of the things that it highlighted that I thought was like very good ideas and that I also think about, but are not very obvious maybe. The first one, as Stefan mentioned a lot, like models are not perfect. They can make errors. So that's like the main thing. We're going to talk more about that. But ChatGPT also mentioned stuff as like machines don't really have empathy, they don't really have intuition, and they don't have personal touch, things that are often critical in a healthcare setting. They also mentioned, or ChatGPT also mentioned, that it's important for a doctor or healthcare personnel to establish trust, which can be hard to do while using machine translation or just using machines in general. So let's zoom in on some of those challenges. First of all, like direct quote from the response, and this is the most important thing. It is important to note that language models are not perfect and can sometimes generate incorrect or inappropriate responses. Machine translation is amazing. I've moved to Spain a couple of months back, and I didn't speak any Spanish. So I've been using a lot of like Google Translate or other machine translators just to make myself understood. And it is quite amazing how good translations you can do, but they are not 100%, and they are far from 100%. Just to show you a couple of examples from Google Translate. So the first one that says "Don't cry now" is translated from Swedish to English. The actual translation should be "Don't push now." Quite a big difference. The next one, "We're waiting for the baby's wife to come out," which in itself doesn't really make sense. No one understands that sentence as it is. But the correct one is "We're waiting for the placenta to come out." And then the last one, from Pashto to English, "Your keys are automatically released," should be "Your stitches will come out by themselves." So this is maybe the most obvious obstacle, that the translations aren't 100% correct. And it doesn't really matter what translation model you're using, the answers will never be, or the translations will never be 100%. But there are also other things that we're looking into when we're developing our app, and other challenges. So the second one I would say is healthcare terminology. So in a healthcare context, like sometimes you use words and maybe it's the exact same word in your language as it is in the patient's language. And like that would make sense. But if the patient doesn't understand that word in itself, it doesn't really give that much to the communication. And since you don't speak the same language, it's hard for the patient to like describe or explain that they don't understand that term. There's also cultural differences. So you need to make sure that the thing that you're translating can actually be said in all languages. For example, it differs a lot between different languages, how important it is to be formal versus informal and how to address people properly. Something that is hard to think about when you're just entering what you want to say into a translation tool. There's also example of languages where they, for example, don't differentiate between hand and arm. They have the same word for hand and arm, or they have the same word for fingers and toes. So trying to explain to someone that they should move their hand and instead talking about the arm, it's quite a big difference. There's also some cultures, as shown in this image, where like having a negation in a question can make the response be very hard to understand. So you don't have you don't have any allergies. In some cultures, answering no would mean that you don't agree with the question, and in some, it means that you don't have allergies if you answer no. So that's the sort of third thing. And then the final thing is that to use translation in healthcare context or use a translation tool, it has to have an intuitive and simple interface. The product will be used to in stressful situations like emergencies, and it will also be used in time-boxed meetings where you don't have that much time, like in triage or other things where you want to be effective. And even if other translation tools are very quick and easy when you want to translate one specific phrase into something else, they can be very hard to use when you want to translate a whole dialogue or when you want to use it for more than just one phrase at a time. So how do we at Care to Translate solve these challenges? Because we can't just give up because it's hard. We need to solve it somehow. We need to help healthcare personnel communicate with their patients. So the first thing we do, and I think this is the key thing that solves many issues, is that we're actually using set phrases. So we don't allow the user to translate whatever they want. We only allow them to translate what we have already given them. So today we have a phrase library of around 3,000 phrases, and those are translated into 44 different languages, and that is what you can use. That is the only thing you can use. What this means is that we can actually define what phrases you should use or we should use in the app. So for example, instead of saying antiarrhythmics, we can translate it to a medicine to help with your irregular heart rhythm. Or instead of saying intravenously, we can say medicine is administered through the tube directly into your blood. But we can also make other sort of improvements to the phrases. For example, can you lie on your back is a very easy question in the context of you're a person talking to another person. But when it's played through a machine, it might be hard to understand. So why not change it to please lie on your back instead to make sure that there's no misunderstandings? Also, the negation that I mentioned earlier, don't you have any allergies, can just be translated to do you have any allergies? So in this way, we kind of decide, but we can also help the user to talk in a language that the patient understand instead of the language that maybe they usually express themselves in. It also allows us to do review with both medical and cultural experts. So we can make sure that a phrase is understood in the target culture, and we can check that a phrase is correct for a medical context. And we can also most obviously fix translation errors. Good examples of this that we have done in the product is the word rectum, that is very easy to understand in English. In Tigrinya, patients don't necessarily understand the word rectum, or they don't necessarily have a word for it. So instead, we just translate it to the part where the poop comes out, basically. And another example is that we have an area called orientation for you to talk about directions to different things as a patient. And like when translating it immediately into Hungarian, it sounded like talking about sexual orientation instead of just orientation. So those sort of things are easier to catch when you do these reviews and have these set phrases. And then the last problem with like having a good interface for it, the only thing we can do, and I think this is one of the hardest challenges, is to try and build a recognizable interface that focuses on usability and simplicity. So that means don't use too many colors. Use colors that are usually used in a healthcare context. So for example, green is a good color for healthcare context, at least in the West. Uh, and also some other things. You can add phrases to the app to explain how the tool works so that you can quickly just say how you're going to use it. These are three examples of phrases where the first one is just saying that you will use this app to communicate. And the second phrase is telling the like the receiver or the patient, that they should nod for yes and shake your head for no, so no cultural conflicts there. And also giving instructions such as show the number with your fingers. Other things we can do is have effective navigation, so you can easily move back and forth between the content in the app. So for example, it allows for easy repetition of previous phrases. Like if you want to translate something multiple times or go back in history, I know that those tools are in other translation tools as well, but maybe not the main focus. So having an app with set phrases, we can allow you to go back and forth, play things multiple times, making sure everything is understood. We can also guide the user to the next step of the session, and we can help the user define and follow standard procedures. So in some parts of healthcare, you have a very standard procedure. So using our app, you can actually set up your playlist so that you have your standard procedure defined in the app, making it very easy for you to move from one step to the next one and getting guided in that way as well. But that's it about like how we solve the challenges that we're facing. And finally, just wanted to talk about like going back to language technology and modern language technology, because it's easy to ask, like, can't we use anything from modern language technology and still be safe? And of course we can. We have found some good examples, and I'm going to show you 2 examples from our product where we have used language models and what they can generate to make the product a better thing to use. So first of all, enhancing the quality of the content. And I'm going to tell you a story about text to speech. So just translating text into audio, basically. And we started doing this with human recorders back in the days. And humans are very good at translating, but they have some issues. For example, humans get tired and can vary in energy. So, for example, when translating a library with phrases up to 3,000 phrases, it can be easy to lose focus and eventually like miss a word or pronunciate something in a wrong way. It's a very exhaustive sort of process. They also record phrases out of context, meaning that they maybe like they can understand that the phrase could be used in a sensitive context, but it's hard to remember that while just recording the phrase in itself. So it can be hard to know what style of voice to use, like if you should be empathetic or if you should pronounce certain words more strongly or something like that. And last but not least, humans don't always have like master things such as audio quality or file size management or volume. So when we're looking at the other end of the spectrum, talking about AI voices or text to speech, uh, they don't get tired and they deliver consistently. They also add the ability to choose your voice style. So you can actually say that the voice should be empathetic or it should be soft. And you can do customizations to how the voice should sound for specific phrases. It also allows you to control audio quality, file size, and volume, just making the product easier to build and easier to maintain. And when I started back in 2019, so we had actively said no to TTS because we felt like the standard was being too bad and it was easy for a patient to misunderstand the phrases because of that. But then just 1 year later, in 2022, we started investigating it again. And that was when we decided to add it for specific languages where we felt like, oh, okay, this is better than human. It's delivering better quality, or it's just a good voice in general. And today, so 3 years later, we're using TTS or text to speech in 37 of our 44 languages. So that's 84% of the languages. And even if it still needs some manual work, like we need to evaluate voices and we need to configure certain phrases so that they are pronounced correctly, it's still like a great and effective tool to make the content better for the users, but also like easier to work with and more effective to work with. And the last example and the last thing of this presentation is using modern language technology to actually find what you're looking for. So since our product is based on these 3,000 phrases, it's hard to get lost and it's hard to find exactly what you're looking for. So what we did was that we worked together with Digital Grammars, the company that Arne is from, and we implemented a search engine that is using natural language processing as the base for it. And what this means is that we can do things such as if you just search for a word or search in the app in general, you can do things such as search for bleeding. And even if bleeding is quite far off from blood, if you just look at character by character, having natural language processing behind knows that bleeding and blood are just different conjugations of the same word. So we can still show those sort of results. We can also add synonyms, such as if you search for drugs, we can still show medications, so it will be easier to find what you're looking for. And the last example, misspelled myalgia. So I've written myalgia, but it still understands that I want to say myalgia, and it also understands that that is related to muscle pain, or maybe a misspelling of mosquito as the second result says. But that's sort of the areas where I feel like it's just where it's perfect to use modern technology, and it's a perfect example of how sort of the working around language content can still be much improved by using these things. So you will hear more from Arne about natural language processing, I assume, but thanks for listening to my presentation.
Thank you so much, Alex. Yeah, I'm of course rooting for you because you're in our team, but this was truly a really good explanation of what we do and a very nice presentation. And I had many questions before you presented, but it seems you answered most of them, such as why don't you just use a digital translator in the tool to be able to add translations on the fly? But you answered that quite well. So maybe another question would be, what would you be most excited about to see coming up, like future developments? Is there anything that you're longing for to happen?
So when it comes to language technology, I feel like it is making so much progress right now. And for example, we're still using machine translation to generate drafts of new phrases. And I feel like the things that I mentioned about context and being able to understand like what sort of context you're using this phrase in, I'm really looking forward to like that being even better in more languages, and just being like closer to like getting closer to 90%, 95%. At the moment, it's, as Stefan said, sometimes 10%, or like it's just a bit too low. So I'm looking forward to better direct translations that you can use as drafts, or you can use to just continue working with something or get inspiration.
All right, thank you so much. And I'm gonna head over to the third speaker who is with us today, and also partly already introduced by Alexander. And the third speaker is Arne Ranta. Arne will speak about powerful grammar-based technology to scale across languages and domains. And Arne is CEO and founder of Digital Grammars AB. And as professor of computer science at the University of Gothenburg, he has led the research project Grammatical Framework, GF, and with the mission to formalize the grammars of the world's languages and make them available for computer applications. So this is quite exciting, even for us at Care to Translate, obviously. And the GF community has created grammars for over 50 languages already. Digital Grammars uses GF to build language application in the mission to improve fields such as the healthcare sector, law, and even technology. So a very warm welcome to you, Arne.
Yeah, thank you, Maja, for the introduction, and also thanks Stefan and Alex for very exciting presentations. I feel a lot of pressure now. Do you see this window now?
Yes.
with a lot of words in it. Can anyone say that they see it?
Yes, we see it.
Okay, so I will start with this demo of how grammatical framework works. So this is really a demo where you build sentences and other phrases guided by a grammar. So it's a kind of a prediction of the next word. And these are the words that the sentence in this grammar can start with. And then I write, for instance, the, okay. And then I see a different set of these fridge magnets. If you, so that's the model for this application. So I cannot, for instance, say the again, but I have to choose a noun or an adjective. And since this is not a medical application, but I will start with something which is yeah, has a doctor in it as a word in any case. The doctor has a yellow car. Okay, and now I have built a complete sentence, and it has been analyzed as this abstract syntax tree, which gives the structure of saying that there is the doctor have a yellow car. Doesn't look very fancy yet, but the thing is that this is the language independent structure. So it is actually rendered automatically to many different languages here. And you can see that even for this very simple language, so the relations between the different words are quite different. So you change their order and there is a different number of words and so on. So the first variation here that was promised in the title was that you have many languages from one common structure, which is kind of promised to be translation equivalents. And then inside any of these languages, so you can get many different variations of the same content. So you have here both sentences, questions in the present tense, negation, past tense, and so on. And then, so this is the demo I wanted to show to give some understanding for what I will then present in a bit more static way. Here and so technology to scale across languages and domains, and as Maija said, so we have the mission to formalize grammars of the world and make them available for computer applications. It's around 25 years now we have been working on this, and this is the current set of languages which has been created by the GF community, and there is a constant flow of new languages. And I already showed this grammar, so how we construct the phrase by predictive parsing, how we generate translations in many languages. We show an abstract syntax tree, so that's the tree that is common for the languages, and then the phrase alignments. And then we showed systematic variations of one phrase. We showed it in Swedish. So now I will apply this to something that we made together with Care to Translate a couple of years ago. So as Alex told us, there is a fixed set of phrases, about 3,000, and we had made an experiment with 135 phrases, such as this one, and the phrase was analyzed with the GF to get this kind of a tree, abstract syntax tree. Then we used NLG, natural language generation, on the level of these trees in order to generate variations of the phrase, and then as a part of the bit adapted to another task, variations in terms of answers to questions. And from this we could then generate from this one phrase that was given, so these different kinds of questions and then their appropriate answers to those questions, as you can see here, at least if you know Swedish, and if you want to see it in German. So that was also then given from the same set of the abstract answer and variation trees. So in the end, we get about 2 million phrases times 4 languages generated from this one given. No, sorry, 4 is 135 given care to translate phrases. Not all of them are useful, I mean, but all of them are meaningful and correct. That's what we can promise. Under the hood, we have this pipeline where we have a phrase which we can parse, either as it is or word by word. Then we have this abstract syntax trees among which we do these manipulations. And then these are linearized to the different languages again. So here is another picture showing one abstract syntax tree. So this comes from another earlier project that we did with Saul Grenska University Ambulance unit. We had 8 languages at the time, so 6 of them are shown here. And again, how the same abstract tree corresponds to the different languages and how the phrase alignments run between those. So advantages of these grammar-based techniques, and I think this was very well covered by Stefan's talk, what the problems are in machine learning approaches. So all of these are almost opposites. So we are having a controlled natural language, which we can make accurate, and by nature it's traceable, so you know where each of the parts come from and why, and then therefore explainable. The other advantage is that it is lightweight, so it runs on small machines, so you can for instance run a pretty large grammar on a mobile phone, or you can compile the grammar into the binary code that we need on a normal laptop, even for these 50 languages and 100,000 words or something like that. We don't need much data, so we don't need billions of words, but we just need kind of one piece of data for each rule. And then it works, therefore, for low resource languages. So in the map, you saw some languages from Africa, for instance, which hardly have, let's say, you can hardly find 1 million words on the web, if even that. So that's one target is that we are working with many players in Africa for building digital technology for those languages. I want to conclude with kind of our latest project, which is related to healthcare, and it is SNOMED. So again, you can think about, if you have heard about SNOMED, it's a standard systematized nomenclature of medicine clinical terms, over 300,000 terms, and it has been translated to a few languages and is being translated to some more. So we have worked, Digital Grammars have worked on it with 2 partners. So one is TalTech, the Tallinn University of Technology Digital Health Unit, I think. And then more recently with Lingsoft, language technology company in Finland. And if you compare with this picture of the abstract syntax and the grammar, so the terms in SNOMED, so we can take them as semantic units, and then the grammars take care of translating them, and then also using them in translations, and then putting them into a compositional syntax, where the you know how the different parts of the term or a text are related. So let's take an example. We have this, this long number is an SNOMED ID, and then it already has these 3 given translations in English, Spanish, and Swedish. If you want to add yet another language, so Finnish is, of course, a good language to have. So this is a Finnish translation. So that's what we are doing is adding languages, and the other dimension at the same time we are adding grammatical information. So it is useful to know the gender of a word where in languages where this is relevant. In Swedish, it's useful to know the gender as well, and the definite form. And in Finnish, it's useful to know all of the 14 different cases of a noun. Because then we can use it for instance, analyzing texts. So if we only have the terms, so we can't find all of their forms in a given text. But this is a passage from a recent PhD thesis from Sahlgrenska University Hospital. And by an analysis, you find these SNOMED terms in here. This is a bit of a mock-up, I warn you, but anyway, so this is how we can do it. And then when we have these IDs and we have the rendering of them to another language, we can translate this to Finnish by putting them into a grammar that has the other words as well, and only the SNOMED terms. So this is one of the intended applications of having SNOMED. So the vision here, which we now have in a joint project with Lingsoft, is that we build SNOMED into a universal grammar of clinical concepts that can be used in text analysis, in translation. We have developed techniques for adding new languages to SNOMED, and then the downstream application is also in different communication applications. So maybe this could help Care2Translate to populate the phrase bank with more phrases. The doctor-patient communication should also be mentioned here, because typically SNOMED has both professional and layman terms for the same concepts. So that's where I wanted to end up with. Thank you for your attention.
Thank you so much, Arne, also for a very great presentation and very informative as well, a bit more technical. And just to give us an idea for a more concrete example of your latest, the SNOMED project, would that be, for example, for patient, how do you call it, information like medical history when they're being transferred, or what concrete usage do you see when you can apply SNOMED?
Yeah, so one usage is exactly that when you have, for instance, a record that is written in professional terms, so you can translate it into this patient language, so to say.
Yeah, I think that would be really great. We at Care2Translate, we get sometimes also phone calls from patients who had maybe visited a doctor in a different country, and their records were written in a different language, and they would like to translate their records still in medical terms, but maybe they could use this kind of technology in the future as well.
Yes, so if you can annotate this document, you can analyze it in terms of this SNOMED concepts, then the translation should come out automatically and in a very reliable way.
Right. Thank you very much. And I'd like to invite Alexander and Stefan back to the panel, and also invite you in the audience to post your questions if you have any in our chat or in the FNS or question and answer field. And now that I have you all three here, I have one question that I would like to ask you. It's quite a big question, but maybe you have an answer. So looking ahead, how do you see the field of language technology evolve in the next 5 to 10 years?
Oh.
Yeah, Arne.
So one thing that is very clear is that there will be more language technology in use. Maybe that's the only thing that I can say with certainty. Your IBM slide was quite interesting, because when they published it, they also had a press release where they said that in 5 years, automatic translation will be the norm. I mean, that should have been in 1955. And every time there is something new in the language technology field, they say that in 5 years we will have solved all of the problems. And I have heard it so many times that, well, you understand, but it's increasing at least, even if not solving all the problems. But new solutions will be found and new applications.
Any input, Stefan or Alex?
Yeah, I can. So basically, what Arne is showing is what's called symbolic representation of knowledge, and that's how AI began. Once in time, you try to build a model the whole world in some graph that you should do it, and it's we kind of left that place, and now we go to this data-driven model building. But actually, there are now people like say, well, there were some good things with that old stuff. We actually know what we inputted. So instead of beginning a model with random initializations, so we have knowledge. What can we provide it in there? So there's actually a field called neurosymbolic AI that we try to merge the old symbolic way of representing knowledge with this machine learning models and see what can go in there. And I think that's an area that actually can be very useful and bring it forward. Then I also have a little bit of a personal twist on this. I actually think that what limits us now is the keyboard when we're working with language. So I think spoken language it's more useful to us, but it's even more challenging actually to process, because you will have so much noise and people have their dialects and stuff like that. So it's even harder problem. But I think that will be the nice experience for humans is actually to speak, not using a keyboard. So that's my hope 5-10 years from now, is that actually can speak instead of typing.
That sounds good, because some of the technology today is of course excluding people who might not be able to write or read. So speaking would include a broader population. But how do you think about inclusion of other languages? Because 100 languages of 6,000 is still a small fraction. Like, how do you select what languages to train? And how will that impact society?
Yeah, so it's a problem, because today we're using computers to learn machines, so you need to digitalize them. And that's the problem with many languages, that there are no digital data available. So I was a group of people trying to do with the small African language, and they found one document that been processed and digitalized was the Bible. So that was available in many different languages. You can start from there and start building models from there now. And it became a community project. So how do you preserve languages that are spoken by older generations? Well, you record them. And then you got audio files, and then I can start processing them. So I think the technology can be used to preserve languages as well. So it's not, but I'm totally afraid that English will be world dominant. And if you look at the Swedish language, how many English words we're using today, it's scary. So it's.
Thank you. And Arne, you have some input here too.
Yeah, just a small addition to this. So we are currently, our main research project academically is called Abstract Wikipedia, which is an initiative from Wikimedia Foundation. And the goal is to generate Wikipedia articles in 300 languages from Wikidata. So it's a kind of a model of the world, but it's a community-built model which has the basic facts, and then we are building grammars to generate texts from these facts. And a part of this is, of course, to multiply the number of languages from 50 to 300. But when we are able to involve the Wikipedia community, so that will hopefully give a big boost to this.
Yeah, sounds like a good idea to crowdsource. And I have another question for you specifically, Anna. The question is, how does the system understand compound words, especially in languages such as Swedish, where there are an infinitive amount of compounds like mat, bord, stol, and so on?
This is actually a very complicated question. So we, because there is no unique semantics of what it means to put two words together. And we have noticed this, for instance, in SNOMED, that you very easily, when you try to, for instance, translate a compound, so you get many different candidates, and some of them make sense and some of them don't. So I think this is basically understanding a compound is like parsing, and in parsing you get many alternatives. So yeah,
Very interesting.
so that's
to listen. Yeah.
but it is, I mean, it is within the technology, and there is nothing special with compounds as such, so maybe that's
Thank
a good
you.
thing.
And another question, since we are in the field of helping healthcare staff and patient overcome language barriers, which traditionally are tried to be overcome by, for example, using interpreters. So the question is, how do you see the impact of AI-based language technology on human translators, interpreters, and even language educators?
Is this to Alex or to me?
Anyone who wants to answer.
I can start because I feel like I think what it does and what is a good thing with like new language technologies, it's kind of forcing us to adapt. It's forcing us to realize that there's no just one way to communicate with someone. You can't just always rely on having a human interpreter there, or you can't rely on like having one tool to make yourself understood. Like you have to implement different sort of tools, and I think that will be very clear in like in the future or in the long run, that to be able to communicate with someone when you don't speak the same language, you can just actually use like a lot of different tools to make sure you're understood in different contexts. As Arne mentioned, like using SNOMED for a specific context where that helps you translate documents, or using like as Stefan, I just loved your example that you mentioned about like socializing, where you're not demanding 100% correct translations. I think AI or machine translation is also a perfect example of how it will change how we can actually build a relationship with with the patients, even when you don't speak the same language. That's from my perspective.
Any other inputs?
No, I think humans are very good at changing behavior. So we have when television come and when books come, people get annoyed. So I think we might not understand today how this technology will change behaviors. I don't think people should think how this telephone actually changed behavior. Or people sitting down now looking at small screens. We didn't think that it was possible 10 years ago. So it's like how this will change. We know that the jobs we do today will not exist tomorrow. So that's for sure. So I think that there will be a lot of change, but we cannot always predict how technology is going to be used and change us in society. That's be open for change. That's the future proof.
And on one question to you, since you have been researching this field for quite a while and building these great models, what is your hope for the future? What are you trying to achieve, or what are you hoping for others to achieve with technology?
Yes, so right now we are quite committed to these two rather big projects, SNOMED and Abstract Wikipedia. And personally, I feel that I should focus a bit more and try to not always to begin new things, but to because it's so easy to, as a researcher, to get driven to, for instance, these competitions where you have to beat some benchmarks and compete with other researchers. And as Stefan said, so these research-driven competitions are quite far from the real world often, because they are purely focused on certain things and ignore everything else. So personally, I want to continue these things that I mentioned and make them more and more useful and realistic and white. Yeah, rather naive and simple answer. Because I think now I see that there is a lot of momentum, and I would also say that these machine learning techniques help. So, for instance, in particular, we're using a technology called universal dependency parsing, which is neural parser, but which we can use as a robust front end or as a source of grammar rules or whatever. So it's so we are not ignoring those techniques, but we want to use them in a tamed way, so to say. And when there are more and more better techniques, so it will also help.
Okay, and maybe the last question, we don't have too many minutes left, but you touched also a little bit up on, Stefan, the language being used, English, and how that will maybe continue, and how do you or anyone of you three see the role of government and private sectors in promoting the development of language technology and making it more accessible to under-resourced languages? What would your what you would like to see? Maybe there is no one answer, but
Yeah, I think that's so. I'll touch a little bit about the public service and how they use technology evolution. I mean, it's from a personal perspective, I think it's kind of silly that American companies now are getting the profits from technology use of public funded research, and it's a complex issue. But for smaller languages, I think there must be some government initiative, actually, and we have initiative in Sweden to build Swedish data sets, as we're building a Swedish GPT model. So there are stuff coming up there, but I mean, all the countries doesn't have the resources to do that. So we as a community, there are some projects going on to it's a hashtag, I think, don't leave no language behind or something like that. So that there are efforts going on to do that, and I think it's a good initiative. We support it. It's part of our culture and history. We should preserve it. I think it's very important to do that.
Thank you. I think these were really good final words. So I'm gonna conclude here and thank you three of being part of this webinar today. Thank you so much for sharing your knowledge. Stefan Palm and Alexander Gyllensvärd and Arne Ranta. It was very inspiring, very interesting, and I think everybody learned something new. And I also, of course, want to thank everyone in the audience for joining us today. And if you would take a moment, please, to give us feedback in the poll showing up in just a second, to give us some insights in how you liked the format today. And thank you again, everyone. Thank you so much. Hope to see you soon. And please reach out if you want to learn more about us or if you have any more questions to our presenters today. Thank you so much.